Okay, here are the first few questions from your assignment. One here, they may not be in the same order for you, but here they are. So x minus 4, x plus 13, we just have to take those two and FOIL them out. We can use FOIL or we can use that grid, it doesn't really matter. If we take our first terms, it's x squared. If we take our outside terms, that's plus 3x. Our inside terms is minus 4x. And that's not 3, that's a 13. Hang on, let me fix that. And our last term, 4 times 13 is 52. It's going to be negative 52. We find our like terms. So our two like terms are the two x terms. So we combine them, and we get x squared. 13 minus 4 is positive 9. And with 52 over there. So we have 1x squared, positive 9x, negative 52. Out of all of these, this one, I think, matches that. This is a dumb response, A and C, because A says none. Oh well. For our second one, the fully factored form of 81x to the fourth minus 1. So here we have 81, we know is 9 squared. So we can break this into a 9 and a 9. And x to the fourth, well, that's x squared squared. And negative 1, we can break it into plus 1 times negative 1. So this is in the form that we see often, a squared minus b squared. And a squared minus b squared is always going to be a plus b, a minus b. So here it will be 9x squared plus 1 and 9x squared minus 1. For 9x squared, we know that 9 is 3x, right? 9 is 3 squared, and x squared is x squared, so 3x times 3x is 9x squared. And 1 is 1 squared, but we can't factor this one any further, because if we FOILed this back out, if we said that this was 3x plus 1, 3x plus 1, like say we thought this was going to be 3x plus 1, 3x plus 1, like that. When we did that, we would end up with a plus 6x in the middle. So if you FOIL back out to check, you see that doesn't happen. You don't get there. So that first term is as good as it's going to get, but the second one, 9x squared minus 1, that's the same as that again. So our first term we leave alone, 9x squared plus 1. And our second term, we can split up like this. We can say that that is 3x plus 1 and 3x minus 1. So out of that, that's this choice right here. And another thing you can do on multiple choice is you can just FOIL these out. You can use the distributive property to figure out which one of them actually comes back to here when you simplify. Next, the area of a square is represented by this trinomial. The sides of the square is this. What's the value of a plus b? Okay, so factor 36m squared plus 84mn plus 49n squared. So here we've got a perfect square, right? 36 is 6 times 6, m squared is m times m. 49 is 7 times 7, and n squared is n times n. So our beginning and our end are perfect squares. Our middle term just needs to be double the, so if I take 6m times 7n, so one of these guys and one of those guys, and double it, that should be my middle term. Let's check. So 6 times 7 is 42. 42 times 2 is 84. And with an m and an n in there, yes, this does fit into our a squared plus 2ab plus b squared kind of mold. So this is a perfect square trinomial. And for a perfect square trinomial, we know that we can get there by just doing 6m plus 7n times the same thing again. So it's squared because it's a square. It's always going to be a square. So 6m plus 7n, 6m plus 7n gets us our original trinomial. and this says it's am plus bn, so that's 6m and 7n. So 6 plus 7 is 13. Next, what's the value of k so that we get a perfect square? So for a perfect square, we have to have that mold, a squared plus 2ab plus b squared. So we know k has to be a perfect square, which doesn't narrow, well, it does narrow it down, because 8 isn't. So it narrows it down by 1. And we know that the middle term has to be double the factors, the a and the b. So we know that this is just 1, right? So 1x squared times 1x squared. So this 1a is 1. And we need something that when we double it, 2 times a is 1 times b. We don't know b. That's going to be equal to 8. Well, 2 times something is 8, b is 4. So in order for this to work, we need to have this to be equal to 4 times 4. B squared is 4 squared. So that's 16. So our trinomial should be x squared plus 8x plus 16. Because when we break this down, it becomes x plus 4, x plus 4. And we can check that with FOIL if we're not sure. And we get x squared from our first terms, our outside terms, plus 4x, inside terms, plus 4x, last terms, plus 16. 4x and 4x is 8x. So x squared plus 8x plus 16 is a perfect square, so this has got to be 16. The checking is always the fastest for these ones, much faster than the factor. Next, the expression negative 5a plus b a minus b is equivalent to. So we've got some choices here. So we have our initial thing, negative 5, a plus b, a minus b. And our choices are a, which says negative 5a minus 5b, and a minus b. So this a minus b here has stayed the same. And what's happened in here looks like the negative 5 has been distributed through. So if we take the negative 5 times a, that's negative 5a. Negative 5 times b, that's negative 5b. And then we still have our a minus b like before. That works. There's no mistake made there. So at the very least, a is correct. But we have a choice for both a and b, so we need to double check b. B says, so we're going to start again with negative 5, a plus b, a minus b. B says negative 5 a squared minus b squared. And remember we have our a squared minus b squared, our difference of squares, and that was always equal to, well, that, right? A plus b, a minus b. So if we ever take any two things, add them once, subtract them the other time, and FOIL them out, we end up in this a squared minus b squared shape. And that's what we've got here. So we could write this as negative 5 a squared minus b squared, and it's the same. That will expand back out to what we started with. So b is also equivalent. So we would have to choose C, both A and B. Okay, I'll do 5 more in the next video.